This problem that we have here is a problem that involves a rational expression, exponents, and radical expressions. And the objective here is to simplify this expression um, to the simplest form. So before we do that, let's make a couple of points clear here. We're not going to work with the radical yet. We're going to work with the exponential expression first and work with the exponents. If you notice here, you have a to the negative x power, all that elevated to the 1/4 power, all those elevated to the negative 1 power. Then later you multiply it by the cubic root of x to the second, and you divide all this by the 6th root of x to the 4th. So before we go ahead and work with the radicals, we're going to work with this x, which is the base, and the different exponents that it has. Now, if you notice, this is what we call a power of a power in here. So this power -8 is affected by the power 1/4, and all those powers is affected by the power -1. So before we try to simplify this, we're going to explain a couple of properties here. So there's a property that says that if you have a number a, which is your base, elevated to the n power, and this number is elevated to the m power, this is what is called the power of a power. So the result of this is you keep your base and you multiply your powers. N times m. For example, if you have the number 2 elevated to the 3 power, and all this is elevated to the second power, as a result you get the base 2 elevated to the 3 times 2 power, which is equal to 2 elevated to the 6 power. Also, this is applicable for negative exponents. So let's say that you have the number 3 elevated to the -2 power, and all this is elevated to the +2 power. So you have a power of a power. So your base is 3, and then you multiply your exponent -2 times +2, and you get, as a result, 3 to the -4th power. Okay. So once you know those properties, then you can go ahead and try to simplify this expression right here. So keep in mind, we're not going to work with the radicals at this point. So if you're not going to work with them, we're going to keep them. So you have x to the -8 power. And applying this property, since 1/4 is a power of a power number 8, you simplify that by multiplying these two powers. We are not doing anything yet with the power -1. So we're going to keep the -1 outside the bracket so far. And then we're going to basically work with it later. This is a multiplication sign here. This is going to be multiplied by the cubic root of x to the second. And all this will be divided by the 6th root of x to the 4th power. Now, before we apply the power of a power for the -1, we're going to simplify this a little bit more here. You have -8 times 1/4. 1/4 is a fraction, so we're going to convert -8 into a fraction to make the work a little bit easier. And how do you multiply fractions? You multiply the numerator with the numerator and the denominator with the denominator. Keep in mind that -8 did not have a denominator. That means that its denominator, once you convert it into a fraction, is the number 1. So this would be x elevated to -8 times 1, it's equal to -8, divided by 1 times 4, it's equal to the number 4. We still have not done anything with the -1 power, so we're going to keep it. And all this is multiplied by the cubic root of x to the second, divided by the 6th root of x to the 4th. Now, if you look at this power, this is -8 divided by 2, and before we apply this power here, -1, we're going to simplify this a little bit more. We will write more, but we will make the job simpler. So this is x, -8 divided by 4, it's equal to the number -2. All this is elevated to the -1 power, times the cubic root of x to the second, divided by the 6th root of ax to the 4th power. Once again, we're going to go ahead and apply here the property that we studied before, which is basically the power of a power. So we're going to multiply -2 by -1, and that gives us the final power. Keep in mind that -2 times -1 is +2, so this is x to the second, then multiply the cubic root of x to the second divided by the sixth root of x to the fourth. And now what we're going to do is we're going to leave the x to the second alone, and then we're going to start working with radicals. So in order to work with these two radicals, in order for you to combine them and try to make this expression simpler, you have to have the same index in order for you to combine the two radicands. So let's go back and see a couple of principles in radicals. How do you know you have a radical expression? When you see the radical symbol. This is the radical symbol. Here you're going to have, which is what we call the index. We're going to call it n, it could be any number. When the number you don't see it right there means that it is the square root, so the index is 2. This is what we call the radicand. So the radicand is the number that is inside the radical. And inside the radical expression with the radicand, you can have an exponent for the radicand, which is m in this particular case. Okay. Examples, you can have the cubic root of 2 to the fourth power. And that's one of the examples that you can have. Now, in order for you to operate with radicals in multiplication and division, in this case is division, so we're going to divide these two radicals, you can combine them on the one radical as long as you have the same index. What does this mean? If I give you, for example, radicand A, we're going to have basically the n root of A divided by the n root of the number b. Since you have the same index, n and n, so you can say that this is the n root of a divided by b. And notice something that I extended the radical all the way down, and you can do this in division or multiplication when the indices of the radicals are the same. If they're different, you cannot combine them. So one example, you can have, let's say that we give you the cubic root of the number 3 divided by the cubic root of the number 2. And to make this a little bit simpler, you can say, since you have the same index, you can rewrite this on the one radical only, and that will be 3 divided by 2, and you calculate its cubic root, or radical 3. Okay. So now, the idea here is try to combine these two radicals, but at this point you cannot combine them because you have an index of 3 and an index of 6. So we're going to try to see if we can simplify one of the radicals, in this case this one right here, to see if we can take it to an index 3 so we can combine them together. So let's see a couple of more examples so you understand what I'm going to be doing here. So let's say that I give you, and these are examples for you to understand how to work with this. So let's say that I give you the cubic root of the number 2. And I give you that divided by the sixth root of the number 3 elevated to the second power. Now, if you notice, both have a different indices, but you look at this one, this index cannot be simplified with the power. Keep in mind that power and radicals are inverse operation to each other, so they can simplify. So the index here is 3, the power inside the radical for the number 2 is 1, so they cannot be simplified. But if you look at this radical down here, you have index is 6, the power for the number 3 is 2, so it is possible to simplify this as 6, because the 2 that is a power here divides the number 6, and the 2 divides itself. So what we're going to do is we're going to simplify here and see if we get the exact same index, and then we combine the two radicals together. So a radical on the numerator stays the same, divided by, okay, yeah, the power is 2 here. So now the question is it 6, which is an index divisible by 2? In this case is true. So 6 divided by 2, it's equal to the number 3. So this index right here now, because you divide the 6 by 2, which is the power inside, it's converted into the number 3, and since you divide the index by 2, you have to divide the power by 2, and 2 divided by 2 is equal to 1, so your exponent inside the radical for the radicand is equal to the number 1. So the way you rewrite this expression is technically this way. Now you know index is 3, You know power inside the radical is 1. So it would be the cubic root of 3 to the first power. Since you have now the same index, so now you can combine these two radical expressions. So on the one radical, this would be radical 3 of 2 over 3. And that's what we're going to try to accomplish here. Now, once again, this index is 3, this index is 6, and we're going to try to convert this index 6 into index 3 to see if we can combine these two radicants in here. Now, the 6 goes with this power right here because it's the same radical. So now, 6 is not divisible by 4, but if you look at the number 6, 6 is divisible by 2, and 4 is divisible by 2. So you can use the 2 and divide 6 by 2 and 4 by 2 and obtain an expression that is equivalent to the one that you had before. So x to the second stays the same. The cubic root of x to the second stays the same. We haven't done anything with it yet. Divided by. And then we'll start simplifying the index and the exponent in the radical expression at the denominator. So we agree that we're going to use the number 2 to divide. So 6 divided by 2, it's equal to 3. So your new index is 3. Since you divide the index by 2, you have to divide the power by 2. 4 divided by 2, it's equal to 2. And now the exponent inside the radical is the number 2. So now you rewrite the expression again, and you have the cubic root of your denominator of x to the second power. Now next, since you have basically the same index, you apply this property right here, that when you have the same indices in two different radical expressions that divide each other, you can rewrite it on the one radical expression and the numerator and denominator together. The x to the second stays the same, doesn't change, and we're going to rewrite the two radicals on the one radical, which is the cubic root of x to the second divided by x to the second. Notice something here now. Inside the radical, so before you calculate the cubic root of this expression right here, take a look at what you have inside the radical, which is your radicand. You have x to the second divided by x to the second. X to the second divided by x to the second is like dividing a number by itself. So this expression right here inside the radical, it's equal to the number 1. So I'm going to rewrite it again, and this is equal to x to the second. We haven't done anything with it yet, times the cubic root of the number 1. And the cubic root of the number 1 is looking for a number that when you multiply it by itself 3 times, which is the index, it gives you the number 1. And that number is the number 1. So then you have x to the second times the number 1. And as a result of simplifying that rational expression, you have x to the second times 1 equal to x to the second. So the result of simplifying the expression, x to the negative 8 elevated to the 1/4 power elevated to the negative 1 multiplied by the cubic root of x to the second divided by the 6th root of x to the 4th, it's equal to x to the second power. So I hope you understood all the process and that this helped you to understand this problem.